What if a single hour for you stretched into 7 long years for everyone you love and know? Think that's just a setup for a cool Hollywood blockbuster? What if I told you this isn't science fiction? This is physical reality, and it's much, much closer than you could ever imagine. Hey friends, today we're going to talk about time. Not about how there's never enough of it, but about its strange and amazing nature. Many of you probably love Interstellar. Remember that thrilling and terrifying moment on the water planet, where every hour the team spent on the surface cost them 7 years back on Earth? Well, that wasn't just a brilliant screenwriter's invention. It's an incredibly accurate and clear demonstration of one of the craziest, and without exaggeration, most important ideas in human history. An idea that turned our understanding of the universe upside down. But to understand how this is even possible, we need to take a little trip back in time. Back to the beginning of the 20th century, to a man whose name has become synonymous with the word genius, Albert Einstein. He wasn't some quirky scientist in a white lab coat. He was a dreamer who wasn't afraid to ask very strange-sounding questions. For example, what if time isn't just the steady ticking of a clock on the wall? What if it can behave like modeling clay, stretching and shrinking? And he found the answer. It turned out that time and space are not two separate things, but a single four-dimensional fabric. He called it space-time. Imagine a huge, tightly stretched trampoline. That's our universe. Now, let's roll a heavy bowling ball onto it. See how the trampoline bends under it, creating a dip? That's exactly what gravity does. Any object with mass, planets, stars, and especially supermassive black holes like the giant Gargantua from Interstellar, presses down or warps this fabric of space-time. And the more massive the object, the deeper and steeper that dip becomes. And now for the most interesting part. Imagine you're riding a skateboard on this trampoline. As long as you're far from the heavy ball, your path is fast and straight. But the closer you get to the dip, the more it distorts your path and slows you down. Exactly the same thing happens with time. Near an incredibly massive object, time literally slows down for an observer. For you, on Miller's planet, only 1 hour has passed. But for your friend who stayed on the ship in a safe orbit, a whole 7 years have flown by. All because the black hole's monstrous gravity stretched their time beyond recognition. Sounds like complete nonsense, doesn't it? Like a fairy tale. But here's the really weird part. This seemingly fantastic theory is confirmed millions of times a second every single day. And the main proof is right in your pocket. Yep, your smartphone. Every time you open your maps and use GPS, you are, without even realizing it, saying thank you to the genius of Einstein. Look, high above us in Earth's orbit, there are dozens of satellites. They're farther from the planet's center, so the gravitational pull there is slightly weaker. Plus, they're hurtling through space at insane speeds, about 14,000 kilometers per hour. Because of these two effects of special and general relativity, weaker gravity and immense speed, the clocks on board the satellites run just a tiny bit faster than ours down here on Earth's surface. The difference is only 38 microseconds per day. Seems like absolutely nothing, right? But if the brilliant engineers hadn't built a constant time correction into the system, your GPS navigator would go crazy. The error would accumulate, and within a couple of days, your dot on the map would be off by kilometers, showing you in the next town over. So yes, the theory of relativity isn't just an abstract formula on a dusty blackboard. It's a fundamental law that makes our modern, high-tech world work. Okay, so we've established that time can be slowed down, and that immediately raises a logical question. Can it be sped up? Or maybe do the most incredible thing, turn it backwards, go to the past and, fix a few unfortunate mistakes. With travel to the future, things are, strangely enough, relatively simple. Theoretically, if we ever build a ship capable of accelerating to a speed very close to the speed of light and send it on a long journey through the galaxy, a surprise will await the crew upon their return. For them, let's say 5 years will have passed, but on Earth, 50. They will become true visitors from the past. But going back to the past is much, much more complicated. Here we hit a wall of logical paradoxes, the most famous of which is the grandfather paradox. For now, fundamental science says a firm no, but who knows what incredible discoveries await us in the future. And all of this, all these mind-bending ideas bring us back to one main, almost philosophical thought. Your time is unique. It flows just for you and at your own speed. Every second you experience is yours and yours alone. It is physically different from a second for a person flying in a plane or for an astronaut on board the ISS. If time is not an unbreakable constant, if it can change depending on speed and gravity, what does that say about our lives, about the value of our memories, about our plans for the future? If your time is your most personal, most unique, and most irreplaceable resource, how will you use it? Think about it. Thanks for watching.